Good afternoon, students. Now we are in chapter 6. So, in this chapter, we will learn about foundations of business intelligence and we will learn about databases and information management. So, for the study cases, we will take one cases from Vodafone Fiji. So they use the new cloud database tools to help them make better decisions. Now let's check how they use the new cloud database. But before we go to the study case, let's check what will you get after you learn the chapter. So after you learn the chapter, you will know the problem of how to manage the data resource in the traditional file environment. And then after that, you will know the major capabilities of database management system, or we usually call DBMS, and why is a relational DBMS is so powerful in the company. The next objectives after you learn this chapter is you will know the principal tools and technologies to access the information from the database to make better decisions and of course to improve the business performance. And later on, you will also know why the data governance and the data quality assurance essential for manage the firm's data resources. Now let's begin with the study case. So in this chapter, we have a study case from Vodafone Fiji. So they utilize a cloud database tools to help them to make a better decisions. As usual, I embed the link of the YouTube to for you to check what is it about. But here in the slide, I give you the article of the study case. Later on, you may read the articles for your better understanding of this case. But now, I would like to give you a glimpse introduction of glimpse explanation about the cases. Okay. So Vodafone Fiji Limited is a wireless telecommunication provider with 760,000 subscribers. So they face challenge in meeting the demands of its predominantly prepaid customer base. So their on-premises system lack the computing power and tools to analyze the data efficiently, especially after the parent company acquired additional telcos. Opting for the Oracle's Autonomous Data Warehouse Cloud and Oracle Analytics Cloud service proved to be a cost-effective solution. And this cloud-based platform will enable the rapid data analysis, which will empower the Vodafone Fiji to tailor promotions and then to target customers effectively and of course to optimize the service offerings. With more than 50 reports available within minutes and significantly faster query times, the company saw a substantial improvement in efficiency. For instance, the data mining procedures that used to take over 2 hours now require only 25 minutes. By leveraging the advanced analytics, the company, the Vodafone Fiji, reduced the inbound calls, which allow the customer service agents to focus on the revenue generating activities. The overall Oracle's cloud solutions enables Vodafone Fiji to handle the increased workloads efficiently and make data-driven decisions to enhance the customer satisfaction and drive the business growth. So the study case was about the Vodafone Fiji Limited, which use a new cloud database tools called Oracle's Autonomous Data Warehouse Cloud and the Oracle Analytics Cloud Service. So after using this kind of tools, they enable rapid data analysis and tailored promotions, and of course can target the customers effectively, which lead to uh, optimized service offerings and of course the business growth and decision making. So with more than 50 reports available within minutes, yeah, and significantly faster query times, which the company saw a substantial improvement in efficiency. So, like I explained before, the data mining procedures, which usually take 2 hours, now only take 20 minutes to finish. By leveraging advanced analytics, the company, the Vodafone Fiji, reduced the inbound calls, which allow the customer agents to focus on the revenue generating activities. So, to conclude, the Oracle's cloud solution it enhanced the efficiency, the customer satisfaction, and of course the business growth for the company. Now, let's begin our study by looking into the problem of managing data resources in traditional file environment. So we would like to compare between the traditional file environment and then the new cloud database tools. So in computer systems, the data is organized hierarchically from bits and bytes to fields, records, files, and databases. While you see the figure in the right side of the slide, you may see the example of the data hierarchy. So a bit is the smallest unit of data with a byte representing a single character. And then the fields, it's a group characters into words or numbers. And for records, it comprised the related fields such as student's name and then course, date, and grade. A collection of records of the same type form a file, while related files make up the database. The each records describes an entity which can be a person, a place, thing, or event with attributes representing its characteristic or qualities. As the examples, as you can see in the picture on the right side, the attributes of course entity includes the student ID and then course, date, grade with the specific value found in the fields of the record describing the entity. And in traditional file environments, the organizational system often develop independently, resulting in multiple files and programs for different functions like accounting, finance, and human resources. And over time, this leads to a data redundancy, inconsistency, program data dependence, and inflexibility, poor security, and limited data sharing. So the data redundancy occurs when the same data is stored in multiple places, leading to inconsistency and confusion, especially with different coding systems. The program data dependence creates the challenges when change to programs necessitate the change to data. The potentially costing millions of dollars, of course, yeah. The traditional systems, of course, also lack of flexibility to deliver ad hoc reports promptly, and of course, struggling with the poor security and data sharing across the organizations, that hindering timely access to accurate information and impeding organizational efficiency. Now let's see how the traditional files are managed. In most organizations, systems tended to grow independently without a company-wide plan. So the accounting, finance, manufacturing, human resources, and sales and marketing all develop their own system and data files. Using the old-fashioned way to handle files will encourage different departments in a company to create their own special computer programs. And each program needed its own set of data, which often overlaps with what's in the main data file. This overlap will cause the problems like having the same data stored in multiple places. It will make it hard to keep things consistent and efficient. Now let's see the major capabilities of database management system, or we usually call it DBMS, and why is a relational DBMS or RDBMS is so powerful for a company. A straightforward definition of database is a collection of data organized to serve many applications efficiently by centralizing the data and controlling the redundant data. Rather than storing data in separate files for each application, data appears to users as being stored in only one location. A single database services multiple applications, as you can see in figure 6.3, instead of corporation storing employee data in separate information systems and separate files for personal payroll and benefits, the corporation create a single common human resources databases. So, a database management system, or DBMS, is a software that helps the organizations to manage their data efficiently and provide the access to it for various applications. So, the software acts as a bridge between the application programs and the physical data files, retrieving data as needed. The DBMS separate the logical view, which users see, from the physical view, which shows how data is stored. This setup allows the different users to access the same data in the different ways. By centralizing data and controlling redundancy, DBMS solves many problems associated with the traditional file system, such as data inconsistency and redundancy. Now let's move to the relational DBMS. So the relational DBMS or RDBMS are widely used across the various computing platforms, with the relational model being the most prevalent. This model represents data as two-dimensional tables or relations wherein each of the table corresponds to an entity and its attributes. There are three fundamental operations are employed to generate the valuable datasets. There are select, join, and project operation. The select operation creates a subset comprising all the records that fulfill the specified criteria. And then join operation, it combines the relational tables to furnish the users with more comprehensive information than what individual tables offer. The next one is called project operation. So the project operation generates a subset of columns within a table, which result in tables containing only a specified information. So as you can see in the figure 6.5 is a relational database. Yeah, we have three basic operation that is used to develop the useful set of data, which I mentioned before in the before previous slides, select, join, and project. So we will see one by one and with the examples. So the select operation, it creates a subset consisting of all records in the file that meet the stated criteria. So select creates, or in other words, a subset of rows that meet the certain criteria. As the examples, we want to select the records, which is rows from the part tables, where the part number, the row of part number equals to 137 or 150. Okay, so 137 or 150. Meanwhile, the join operation, it combines the relational tables to provide the users with more information than is available in individual tables. So as the examples, we want to join part table, the part table here, and the supplier table into a single new table. Okay, so we use the join operation. Meanwhile, the project operation creates the subset consisting of columns in a table. Permit the users to create new tables that contain only the information required. For example, we want to extract from the new table only the following columns, for example, yeah, the part number and then part name, supplier number, and supplier name. So we will use the project operation. In a relational database, the rows represent records for various entities, while fields denote the attributes associated with each entity. The key fields are utilized to uniquely identify the individual records, with the primary key serving as the designated field in the table for this purpose. Additionally, a foreign key refers to a primary key used in a secondary table as a lookup field to identify the records from the original table. This structure enables the efficient organization and, of course, to retrieve the data within the database, which facilitate effective data management and analysis. A relational database structures data into tables with two dimensions. Presented here in this figure, the tables depicting the entity supplier and part, demonstrating how each table represents an entity along with its characters. The supplier number serves as the primary key in the supplier table and acts as the foreign key in the part table. Now let's see the capabilities of database management system. So, the data definition capability within a database management system serve to outline the structure of database content, allowing for the creation of tables and definition of field characteristics. Complementing this, a data dictionary, whether automated or manual, the catalogs definition of data elements and their attributes. Meanwhile, the data manipulation language facilitates operations like adding, modifying, deleting, and retrieving data from the database. The SQL, or Structured Query Language, stands as a prominent example of such a language, which is commonly employed for the database interactions. Additionally, the user-friendly tools in platforms like Microsoft Access it simplified the SQL generation. Moreover, many DBMS offer report generation functionalities exemplified by tools like Crystal Reports to craft policed report from the database data. So this is the Microsoft Access screenshot. As you can see here, the Microsoft Access has the rudimentary data dictionary capability that displays the information about the name, description, size, type, format, and other properties of the field in a table. The data dictionaries for large corporate databases may capture the additional information, such as the usage, the ownership, who in an organization responsible for the maintaining the data, and then the authorization, security, and the individual's business function programs, and of course the reports that use each the data element. And the Microsoft Access, you will also find the feature that enable the users to create queries by identifying the table and the fields they want and the results, and then selecting the rows from the database that meet particular criteria. These actions in turn are translated into SQL commands. So in this picture also illustrates how the same query as the SQL query to select the parts and suppliers would be constructed using the Microsoft Access query building tools. Designing database involves understanding data relationship types, usage, and company-wide data management needs. It compasses conceptual and physical designs where the former abstracts of the database from a business perspective and the latter demonstrates its arrangement on storage devices. The design process identifies relationship among the data elements and eliminates the redundant database elements. It determines the most efficient way to group the data elements to meet the business requirements and the needs of application program. Normalization streamlines complex data structures in a relational database to minimize the redundancy and optimize the efficiency. Referential integrity rules enforce the consistency in relationship between the tables. The entity relationship diagrams document the data model, illustrating the entity relationship. The proper data modeling is crucial for effective system functionality, as exemplified by famous footwear database design, issues the hindering inventory management and adaptability. Referential integrity rules are implemented by relational database management system to ensure that the relationship between tables remain consistent. These rules prevent the actions that would create inconsistencies in the data, such as adding a record to a table that references a non existent record in another table, or deleting a record that is referenced by records in other tables. By enforcing referential integrity, the RDBMS helps to maintain the data accuracy and the reliability throughout the database. The process called normalization is illustrated in figure 6.9 where and 6.10 where creating small, stable, yet flexible and adaptive data structure from complex groups of data. In the particular business model here, an order can have more than one part, but each part is provided by only one supplier. If we build a relation called order with all the fields included here, we would have to repeat the name and address of the supplier for every part on the order, even though the order is for a part from a single supplier. So, this relationship contains what are called repeating data groups because there can be many parts on a single order to a given supplier. A more efficient way to arrange the data is to break down the order table into smaller relations with each of the describe a single entity. If we go step by step and normalize the relation order, we emerge with the relations illustrated in figure 6.10. When one table has a foreign key that points to another table, you may not add a record to the table with the foreign key unless there is a corresponding record in the linked table. So, as the technology go advance, the traditional relational database model faces challenges in accommodating the evolving needs of storing and managing vast amount of diverse data. In response to this, companies are increasingly adopting non-relational database technology, often referred to as NoSQL databases, which offer more flexible data models suited for handling the large datasets across the distributed systems. These databases, exemplified by Oracle NoSQL database and Amazon Simple database, cater to the demands of cloud computing and can efficiently manage structured and unstructured data from various sources. Furthermore, the cloud databases such as Amazon Relational Database Service and Google Spanner provide scalable and distributed storage solutions which enable global synchronization of data across the numerous locations. The blockchain technology, decentralized transaction verification, and data security, which eliminate the need for a central authority. Utilizing a distributed ledger across a network of computers, its transaction is recorded as an immutable block with a timestamp and link to the previous block. The blockchain's encryption ensures the transaction integrity, making it appealing for financial, supply chain, and medical record applications. It streamlines the verification and cost reduction benefits along with the smart contracts, which simplify the transaction systems for the firms. Moreover, the blockchain support cryptocurrencies like Bitcoin and Ethereum, showcasing its potential for securing transactions in various industries. In a blockchain system, a user initiates a transaction which could be financial or data related. And this transaction is then broadcast to the network of computers for verification. These computers, called nodes, ensure the transaction is legitimate. And then, once verified, the transaction is bundled with the others into a block. If valid, the block is chronologically added to a chain of existing blocks, creating a permanent record. With the block added, the transaction is considered complete. Businesses use their databases to keep track of basic transactions such as paying suppliers, processing orders, keeping track of customers, and paying employees. But they also need databases to provide information that will help the company run the business more efficiently and help the managers and employees to make a better decisions. If a company wants to know which product is the most popular and who is its most profitable customers, the answer lies in the data. So now in the next topic, we will learn the principal tool of the technology for processing the information from database to improve the business performance and to make the decision making. Before that, we would like to know what challenge inside of the big data. So the challenge of big data arises from the vast volumes of unstructured or semi-structured data generated by the source like the web traffic and social media content and sensor data which traditional relational database management systems struggle to handle. So the big data is characterized by its extreme volume, variety of data types, and velocity of processing. The organizations are interested in big data because it offers insight into the customer behavior and the market trends and many more. However, to derive the value from the big data, the organizations need new technologies capable of managing and analyzing these large datasets. Let's see how the business intelligence covers this problem. So, business intelligence infrastructure now includes tools like data warehouses, head up, and in memory computing to process and analyze big data alongside the traditional enterprise data, which enable the businesses to gain concise, reliable insight across various data sources. Now we will talk the tools. Now we talk the tools one by one, okay? So the first one will come from the data warehouses. So the data warehouses are vital tools for analyzing corporate data, which store both current and historical data relevant to decision makers across the organizations. These data are sourced from various operational transaction systems and external sources, and then transformed and structured for management reporting and analysis before being loaded into the warehouse. While warehouses provide access to data for users, They maintain the data integrity by preventing alterations. Additionally, they offer query tools, analytical capabilities, and reporting facilities. Companies may opt for enterprise wide warehouse or smaller, decentralized data marts tailored to specific user groups, such as marketing and sales teams. For instance, the Barnes and Noble utilize the data marts to manage the different types of sales data and ensure the focus insight for specific business areas. The next one is Hadoop. Hadoop is a crucial tool for handling vast amounts of unstructured, semi-structured, and structured data that traditional relation database and data warehouse struggle with. Managed by the Apache Software Foundation, Hadoop enables distributed parallel processing across inexpensive computers and breaking down the big data problems into manageable tasks distributed across the thousands of nodes. Its key service includes HDFS for data storage and MapReduce for parallel data processing. The Hadoop can handle diverse data types like transactional data, social media feeds, web server logs, and multimedia content. The major companies like Yahoo and Nextbio utilize the Hadoop for user behavior for tracking and genomic research, respectively, while top database vendors offer their own Hadoop distributions or complementary tools for data analysis. The next one we have in memory computing. So, in memory computing offers a solution for efficient big data analysis by utilizing a computer's main memory, or we call it RAM, for data storage instead of conventional disk storage system. This approach eliminates bottlenecks in data retrieval and significantly reduces query response time. With large datasets residing entirely in memory, the complex calculation that once took hours or days can now be completed within seconds, even on the handheld devices. Advances in computer hardware technologies such as high speed processors and falling memory prices have made in memory processing feasible. And for analytic platforms, it's developed by the commercial database vendors offer specialized solutions for analyzing large datasets efficiently. These platforms combined relational and non-relational technology which optimize for query processing and analytics. Once data have been captured and organized using the business intelligence technology we have just described, they are available for further analysis using software for database querying and reporting, multidimensional data analysis, OLAP, and data mining. This section will introduce you these tools. The first one is called OLAP, or it stands for the Online Analytical Processing. It facilitates the multidimensional data analysis, which allow the users to examine the data from various perspectives using multiple dimensions such as product and the pricing, regions, and time period. By employing the OLAP, Users can swiftly retrieve online answers to complex queries, even from the extensive databases spanning multiple years. For instance, a product manager could utilize OLAP to analyze sales figures comparing the actual sales of washers in different regions with projected sales over various time periods. As you can see in this figure 6.14, it shows multidimensional models that could be created to represent product, regions, the actual sales, and projected sales. A metric of actual sales can be stacked on top of the matrix of projected sales to form a cube with six faces. If you rotate the cube 90 degrees one way, the face showing will be product versus actual and projected sales. If you rotate the cube 90 degrees again, and then you will see the region versus actual and projected sales. If you rotate 180 degrees from the original view, you will see projected sales and product versus region. So the next one is called data mining. So the data mining offers a discovery-driven approach to extract the insight from the large databases by uncover the hidden patterns and relationship to predict the future behavior. Unlike the traditional query-based analysis or OLAP, which require users to have specific questions in mind, data mining delves into the data to identify the associations, sequences, classifications, clusters, and forecasts. As the examples, it might reveal that certain supermarket shoppers tend to purchase Coca Cola when buying corn chips, especially during promotions. These lead to managers to decision making. And the data mining also predicts the future behavior, such as the likelihood of customer leaving service, enable proactive retention strategies. The next one is called text mining. So the text mining and web mining are crucial techniques for extracting insight from unstructured data sources, which constitute over 80% of the valuable organizational information. The text mining, in this case, the tools enables businesses to analyze unstructured text data from sources like emails and then call transcripts and social media to uncover patterns and sentiments. For instance, the sentiment analysis helped the companies gauge the customer opinions about products and services. The Kraft Food, for example, utilizes sentiment analysis to understand the conversations and the preferences across the various online platforms. On the other hand, web mining explores patterns and trends from the face data available on the internet. It compasses content mining, which extract knowledge from the web page content, and then structure mining, which analyzes website structures, and the usage mining, which examines user interactions data. Through the web mining, businesses can gain insight into the customer behavior, evaluate the website effectiveness, and assess marketing campaign success, ultimately informing strategic decision making. So the companies increasingly utilize the web to provide the access to their internal databases for customers and the businesses partners. Through the web, browsers or apps, the users can retrieve data from corporate databases hosted on dedicated servers. The middleware translates the web request into SQL commands processed by the database management system, and the application server often running on dedicated computers, which facilitates the transactions between the web server and the backend systems or databases. The web access offers advantages such as user-friendly interfaces and the minimal changes to the existing databases. This approach has led to increased efficiencies and new business models. The social networking giant like Facebook, it relies on the web-enabled databases to manage user profiles and content. So overall, the web-enabled databases have transformed access to information in both the private and public sectors, driving the innovations and, of course, the business growth. Next one is about the data governance. So, the data governance is crucial for maintaining accurate and reliable business data, which ensure it's readily available to those who need it. This involves establishing policies and procedures for managing data as an organizational resource, which cover aspects like sharing, disseminating, standardizing, and securing the information. So, the data quality assurance is critical for the organizations relying on data for operations and decision making. Inaccurate, untimely, or inconsistent data can lead to operational and financial issues, including the incorrect decisions and financial losses. The Gartner Incorporation reports that over 25% of critical data in large companies' databases is inaccurate or incomplete. So, the many data quality issues stem from redundant and inconsistent data produced by multiple systems, which highlight the need for consistent data naming and definitions across the business areas. The data quality problem often arises from errors during the data input, particularly as businesses move online, allowing the customers and suppliers to update systems directly. So now the data quality audits. The data quality audits and cleansing activities are also essential to identify and correct the faulty data, which ensure the consistency and accuracy across the databases. The failure to address the data quality issues can have the severe repercussions for both businesses and individuals, which also impact the financial well-being and employment opportunities. A data quality audit involves a structured examination of data accuracy and completeness within an information system, which can be conducted by surveying the entire data files, sampling from them, or gathering the end user's perceptions of quality. On the other hand, data cleansing employs specialized software to detect and rectify incorrect, incomplete, improper formatted, or redundant data. It ensures the consistency among the different sets of data, originating from separate information systems, thus enhancing overall data integrity and reliability. Now let's summarize what we have learned today. In a traditional file environment, managing data resources poses several challenges, including the data redundancy, inconsistency, program data dependence, inflexibility, poor security, and lack of data sharing and availability due to independently developed files across functional areas. So the DBMS addressed these issues by centralizing data management, minimizing redundancy, and ensuring the consistency. Our relational DBMS offers powerful capabilities including the data definitions, data dictionary, and data manipulation language functionalities. It organizes data into tables with rows and columns, which enable the easy retrieval and manipulation based on common data elements. Other data management technologies like data warehouses, data marts, head op, in the memory computing, and then analytical platforms and OLAP, it facilitates the assessing and analyzing a large datasets for improved business performance and decision making. The data governance and quality assurance are also essentials for ensuring the accurate, complete, and consistent data, requiring organizational policies, data standards, quality audits, and data cleansing software to maintain the data integrity and reliability. Okay, that's all of the chapter 6. I will see you in the next chapter. And if you have any questions related to the chapters or related to the assignments, just send me email on my email account. Okay? Bye bye.